Hello class, I hope everyone is doing great when they start watching this video and everyone's having a great day. Today we're going to be talking about chemical reactions, which I think might be my favorite part of chemistry, or one of the most fun parts, because we get to see a lot of different kinds of reactions. We get to see things happen and watch some fun experiments and for examples. So there are a lot of videos that I have attached to this one, and that's just so that you guys can see a lot of different kinds and maybe tie things firsthand into what you're thinking. So of course, I always like to start with some questions to get us thinking. So my first question is, what are some examples of reactions we have learned about this year? So can you guys think back to Partial 2, Partial 1, and try to remember any kind of reaction that we've talked about that you've seen? The ones that come to mind for me are photosynthesis and respiration, even though we've talked about several other different ones with water chemistry, and how macromolecules are formed, how DNA is formed. But the main ones we really looked at, I was thinking, were photosynthesis and respiration. What about any other reactions that you know of that maybe you see on a day-to-day basis or see or know about? So the things that I come to mind for me is fire. Anytime we see fire, it is a type of reaction. We'll learn about that today. Rusting. So if we see metal, old metal starts to get really old, kind of get a little orange to it, and maybe there's some holes in the metal, that's rusting. That happens all the time. Our digestive system has a lot of different reactions. Our whole body has a lot of reactions as well. So there's lots of examples. So our objectives by the end of today, I hope we'll be able to list all 5 types of chemical reactions, be able to describe each type of chemical reaction, and then be able to classify a reaction based on a chemical formula. So our chemical reactions a chemical reaction is defined as a process of elements rearranging to form a new product. So when we talked about photosynthesis, we would take CO2 and water and make glucose or sugar and oxygen. So we're rearranging our water and our carbon dioxide to make a new product. We have 5 main types. We have a synthesis reaction, a decomposition reaction, a combustion reaction, and then we have single displacement and double displacement. And we'll learn about each one of those. I found this video does a really good job explaining it. It really helped me understand it better, so I'm going to have you guys watch it as well. It is a little bit longer, but I think it does such a good job that I really want you guys to focus during this video. So please pause this one and go watch our friend explain this, and then come back, and maybe hearing it from me will also just help reinforce it. So, synthesis. A synthesis reaction is a reaction in which a compound is made from simpler materials. So we will abbreviate or use variables for a lot of our examples. So just like in math class, when we can use variables in place of numbers, we can use variables in place of elements or in place of compounds as well. So when we're looking at this, we have A plus B goes to AB. So this is saying that any element, we could pick an element on the periodic table, let's say Na, or sodium, plus, let's pick chloride, Cl, goes together to make NaCl. So that is one example. When I think of this, and we'll practice this later, I think of bringing my hands together. So I like to, or it helps me to put some motions with the type of reaction to help me learn. So I think of taking both my hands and bringing them together, almost like I'm going to hold hands with hold my own hands. So we're taking 2 separate things, one hand, and bringing it together to make one thing together. And my example is salt, NaCl. Here's an example of a synthesis reaction. So please go watch that. Just to see the coolness of what chemistry can be. we have the next one is our decomposition reaction. So this is a compound is broken down into simpler compounds or elements. So this is the exact opposite of our synthesis. So I like to, first we have AB goes to A plus B. So I think of pulling our hands apart. So if we start with our hands together, as we finished our synthesis example, we're going to pull them apart into our two separate hands. Our examples are calcium carbonate can be broken down into calcium oxide and CO2, or this is a better one, and the one that you'll be watching a video on is hydrogen peroxide, which is H2O2 gets broken down into hydrogen and oxygen, H2 and O2. So this is a really fun, you guys might have done this before, where you make elephant toothpaste, but they obviously make a big bunch here, so please click through that and see the fun reaction. There's lots of examples with elephant toothpaste, and that's all just a decomposition reaction. Then maybe the one we might be most familiar with is a combustion reaction. So this one is a very specific reaction, but it's a compound made of carbon and hydrogen reacts with oxygen gas to produce carbon dioxide and water. Or, to put it in our variable terms, we have CXHY plus O2 goes to CO2 and H2O. So what this is saying is we have any number of carbons and any number of hydrogens coming together with always with oxygen to make carbon dioxide and H2O. So anytime you see, especially these groups of things coming together in this way, these specific elements and compounds, it's going to be combustion. And so when I think of combustion, I think of heat. So the motion I like to do to help myself remember this is to rub my hands together, because it makes it really warm. It actually doesn't take long to get my hands really warm, and that is combustion. So our example, we have CH4, O2 plus CO2, and water. So lots of different kinds. This one is about a rocket making a lot of combustion to have a rocket fly. So that was really fun. Our single displacement is next. We have single displacement, which is one element starts by itself and replaces another element in a compound. So we have A, which is going to go and react with a compound BC to make AC plus B. So I like to think of, we have our two separate hands. One of our hands has one finger, the other hand has two fingers. I like to bring them together, hit them together, and then switch my hands so that maybe my left hand started with one finger. After they hit, my left hand has two fingers and my right hand has one finger. But this is kind of, like our video said, the saddest of the reactions, because this A is stealing the C. So it's stealing and kind of pushing or removing this B out of the way. So it's kind of a sad reaction because we kicked one person all out by themselves. And our example is iron plus copper chloride, that's how you pronounce that, goes to copper plus iron chloride. So here's our example for this one. And then finally we have double displacement. So this is a lot like single displacement, but where both change. So this is the positive and negative ions in two compounds switch places. So we have AB plus CD goes to AD plus BC. So when I think of this, I think of my motion I like to do is both my hands each have two fingers up. They come together to hit each other, and then they go apart. But we can't really, you could try to switch your fingers, but you still have two fingers on each side. But our example is looks something like this. We have this Ba and chloride reacts with sodium sulfite. So this Ba is going to come take the place of this Na, and this Na is going to take the place of the Ba. So we're just switching places. We can see it up here too, probably a little bit simpler. This A is going to, and the C are just switching places and nothing else. So that we get AD plus CB. And here's our last video of an example. This is the summary of everything. So we have our 5 reaction types. We have our generic form, which we use variables for. We can see we're using A, B, C, and D for everyone except for our combustion one. Our combustion one always has to do with a carbon and hydrogen, with oxygen, carbon dioxide, and water. So, and then we also use some of the examples. So, I hope that made sense. I hope that you guys enjoyed the videos as you went alongside and got to see some fun reactions. I wish I could do them in person with you guys, but we just can't at this moment. So if you guys have any questions, as always, please let me know.